Okay, well, here was the quiz problem. Now I gotta observe. Everybody made a perfect score or the near perfect score on the homework, okay? And the homework involved problems like this. Um, Not exactly like this. The last couple of problems, and when I look at those last couple of problems, uh, yeah, six people, there were six attempts over the two problems of three people, okay? And five of the six attempts were successful. So my question is, and this question for you, I'm not uh, criticizing you or saying anything bad about you, but just want to give you a little advice. Uh, are you taking notes when you do these things? How many of you wrote down the equations or the rules for these two things? Okay, did you write them down? If you didn't reinforce them. And if you were looking at the rules while you did the problems, you weren't pulling those rules out of memory. Okay, you put everything away when you do a problem and see if you can do it. Then if you can't, go ahead and start looking, look at the videos, look at the stuff. But that tells you that you don't have what you need, and there's where you need, just I suggest, to make a note. Or something I should have known, thought I knew, but I didn't. Okay, and I had to look for help. Because of course you need to retain these things. That's just a little advice on one way to approach the work. Okay, I give you a lot of advice on how to approach the work. And everybody in here, if you're in my class, everybody's passing the course. Okay. Uh, and if you're not in my class, I probably don't know, but I assume you're doing okay because you're still here. Okay. And we want to, make sure you don't do just okay, but do really well because I think everybody's capable of it. Okay, well, end of advice. Let's look at the homework. So let's look at the problem. We can apply this law if we got the sum of two logs, right? Of course, we can't just apply it here because we don't have a log base 2 of something plus a log base 2 of something. We have a log base 2 of this. There's a 2 times the log base 2 of this. Well, the second rule takes care of that. Okay. This would be the log of AB. So addition with logs becomes multiplication of the things you're taking logs of. Sometimes you need this. This is a log of B raised to the A power. Okay. So you get this kind of hierarchy of operations. If you do the order of operations, at the top of the hierarchy is raising to a power. That's the first thing you do, right? Then you have multiplication, division. Then you have addition and subtraction. Well, look here. We've got an addition that becomes a multiplication. That's like from the third tier up to the second. Okay, so I'm going to write this down because it might be helpful to you. And if it isn't, you don't have to remember it, but you have the hierarchy. Operations. You got raised to a power. You have multiplication or division. You have addition or subtraction. Let's just call this level 1, because that's the first thing you do. I mean, of course, the first thing you do is order the grouping, but you know that. I haven't seen any serious mistakes from anybody on grouping, okay? Or an order of operations. You seem to be okay with all that stuff. Okay, this is level 1. Call this level 2, because you do all these first, you do all these second, and then you do these third. One way to remember these rules is rule one, the way I've written it, takes you from addition to multiplication. Okay? So call this rule one, call this rule two. Rule one takes you from level two to level one. Oh, sorry. Takes you from level one to level two. Can't read my own hierarchy. Okay? Rule one. As an addition of two logs, it becomes a multiplication of the things inside the log. So it just becomes a multiplication. And then level two, the rule two takes you from level one, where you have a multiplication, something times the log, becomes a log of something to a power. Okay? If that's helpful, give you a minute to digest it if you want to write it down or whatever. It's important enough. And again, I'm not going to test you on whether you know that diagram. But of course, it would be good for you, depending on your learning style, to remember that diagram at the beginning of a test, write the thing down. So you don't have to pull it out of memory when you're under more pressure in the middle of a problem. Okay? Typically, I see on a test where you're not given any formulas, I see people write down a bunch of formulas that they've memorized. Matter of fact, typically I see them write down too many formulas because many of them just follow from others. And, they don't know the connection, or they're not secure with that connection. Well, that's okay. If you want to memorize 30 formulas, we only need 6. That's fine. It's a good exercise in memory. Okay. But I see that sort of thing on tests. That's mostly, like in physics class, where there are a bunch of formulas that you can memorize if you want to, but there are maybe 2 handfuls of things you really need to know. You don't need 100 formulas. You just need 10 principles. Now, we're not at the level of calculus-based physics here, with the level of the first semester of pre-calculus. So, on the exam, I will write down a couple of expressions. Okay, just while we're on the subject, I'll write down negative b, maybe negative b plus or minus the square root of 2b squared minus 4ac all over 2a. Or maybe I'll just write down the square root of b squared minus 4ac and expect you to know the rest. Okay? Now, really, I expect you to know the quadratic formula. I think if you've done the problems and written it out, instead of copying it down from something you're looking at, write it out. If it's involved in a problem, you write the thing out. You don't look at anything. Then if you have to look, you say, I didn't remember everything. Well, I think that's right. Well, look back. By the 5th problem you do, you'll have it memorized. And if you reinforce it every once in a while, you'll just know it. And if you review it for the final, it'll come back to you because you will have processed it. Okay? Now, again, I'm offering a lot of advice. It's just advice on how to learn this stuff and how to retain it, at least long enough to pass the exam. And really, if you're in pre-calculus 1, you're going to need to retain it through a couple more math courses. Okay? It's all fundamental. Okay? Now, not every math course you take will involve logarithms, but these are actually pretty easy things to remember. People are usually successful at remembering these and applying these laws because they practice a little bit. All right, well, again, I'm going on and on. So let's apply these rules to this equation. What's the first rule you're going to apply? Just show me, number 1 or number 2? What do you think? Can you apply rule 1? Tell me yes, no, or I don't have a clue. Okay, I see a couple of no's. You can apply it for a reason I just said, but of course, nobody absorbs 10% of what I say. Okay. And I didn't either when I was listening to lectures. Had to work it out for myself. Okay. Anyhow, You can't apply rule one because rule one doesn't have anything in front of these logs. This rule, or this expression has a two in front of this log. Rule one doesn't apply. Okay? But if we use rule two, we'll get something that does apply. So quickly write down, what does rule two tell you can do with this? Rewrite the equation. You got log three, log two, with x minus three plus something equals three. What goes here if you apply rule two to this expression? Write it out. Okay. Okay, so what does this become? Well, A would be like the two, right? And x plus four would be like the B. Okay? So the x plus four is going to stay there because that's B. But the exponent is going to become the number out here. Okay? So that's going to be log base 2 of x plus 4 squared equals 3. Now, apply rule 1. You got the sum of two logs. What's rule 1 tell you can do? Okay, some people have a little difficulty with this. Look here, this is like log A plus log B, isn't it? What's A? It's the x minus 3, right? What's B? It's the x minus 4. X plus 4 squared. Okay? And what's this say? I'm not going to write an equal sign because you might confuse the equation. Log A plus log B is log A times B. So you get log base 2 of x minus 3 times x plus 4 squared equals 3. Okay. Not totally difficult. You just got to practice it and learn to look at it and see what A and B are. Okay. And you've done more complicated things than this successfully. Okay. This is not particularly difficult, but you've got to practice the rule. Okay, well, what do we do next? Well, we change this to exponential form. We write two to the third equals x minus 3 times the quantity x plus 4 squared. Now you've done enough problems if you've done them in the appropriate manner by actually learning from them rather than using all kinds of materials. Okay. And for the pattern of your work, it doesn't look like anybody's, you could be fooling me. And it's okay because, I mean, it's your choice. If you want to let ChatGPT or you want to just look up the solutions of these problems, they're going to be there on the internet and you can copy them down. And for the pattern of the work, I have seen several people in my pre-calculus class who were doing that. None of them passed the test. Okay. Even though they're smart, I could tell in class, but approaching the problems the wrong way. And there's nothing's more wrong than just copying down somebody else's solution. You don't learn a thing from that unless you got a 200 IQ, in which case you don't need to look up the solutions. Okay. So there, and of course, what rule do we do here? It doesn't hurt you to write down the rule. Don't look it up, write it down. Okay, so you write out A to the B equals C And then you write down, well, let's do b to the a, because we want b to the a. Log base b of c equals a. Okay. That's one you should be having nightmares about every night. Okay. You should be dreaming about it until the nightmares become just wonderful dreams. Well, maybe not. But anyhow, you get the idea. You need to internalize this stuff. Otherwise, it won't be there the way you need it to be on the test. Okay. So if we apply these rules, and I'm not going to go through the details, just look at what A, B, and C are for this expression. Okay. Yeah, well, it's log base 2, so B has to be 2. So there's the 2. Of x minus 3 times x plus 4 squared. Well, that's your C, so it goes here. And there it is. Okay. And then it's log base B of I said that right? I think it is. Log base B of C. Okay, so C's there on the other side of the equal sign there, and here's here is the exponent now. There's the equation. Now, can you solve that equation? Probably not. I can't solve it. I don't think I can solve it because I don't think there's a rational solution. Just because of probabilities, I haven't tried to solve it. Maybe there is. Maybe we luck out. But just to kind of review that, we can expand this. So we're going to get what? X squared plus 8x plus 16 multiplied by x minus 3 equals 8. Okay, squaring x plus 4, we get this. 2 to the third is 8. We still got the x minus 3. We've got to multiply it here. Doesn't have room below, so let's just write it here. We're going to get x cubed. Then we're going to have, let's see, negative 24x and 16x. That's negative 8x. And then we're going to have what? Okay, we have x times 8x, that's 8x squared. We have minus 3 times x squared, which is negative 3x squared, so that's 5x squared. Then negative 3 times 8 is negative 24x. Negative 3 times 8x is negative 24x. This is 16x. There's my negative 8x. I got that, but needed to do the order. Minus 48 equals 8. So we got x cubed minus 5x squared minus 8x minus 40 equals 0. Now we can search around for 0, something that makes this 0. You know, 1 certainly is going to work, and negative 1 is going to work either, because all three of these have the same sign. Well, we got one sign change, so it's unlikely we're going to find something. We could try 2, we could try 3, but I think my instinct tells me that the value of x makes it 0 is going to be less than 1. Because otherwise this is going to get too powerful. But maybe not. Anyhow, we do all that. And I'm not explaining all that in detail. That's something that you would know from the previous chapter that you were tested on. Okay. So the point is, it's probably hopeless to solve this. Okay. Other approximation techniques and so forth that we're not doing much with, just because of all the confusion in this semester and the disasters and stuff like that. So there's a picture of how you can use these. Those laws are very important. Okay. See if I can do this. And again, that's almost equivalent to one of the problems, two of the problems you had on the homework. You might want to go back and review those and see if you can solve them now without looking at anything else, including the solution, whatever it was. Okay. Here's a table. Okay, now let me think. I want to do this. Okay, let me make it pretty simple. Um, Now in this case, f of x equals a times b to the x. I'll put a question mark on that, because it might or might not be so. So tell me what you think A is and what B is. As I would expect in any class, a pre-calculus class, or this co-requisite support class, most people have a little trouble figuring out how to start. So I'm going to give you a simple algorithm, okay? Simple rule, okay? And I'm not going to tell you, I'm not going to write out the rule, I'm just going to do it because it's so obvious. What am I doing? I'm dividing each number by the next one. Okay? So what do I get? Well, every one of these is 2, isn't it? Okay. You have to get into big numbers. If the number's a little uglier than this, you might need a calculator to divide it. But if you always get the same thing, well, that's your base. That's B. Here's 12 over 62, 24 over 62. Okay. Looks like B equals 2. So f of x equals a times 2 to the x. Just a vertical stretch of your toolkit exponential function. Okay? Makes sense? Okay, well, what would the value of a have to be then? Figure out what a would have to be. Okay, I'm going to tell you. So we can write the third row as f of 3 equals 24. So that f of x is a times 2 to the x. I got 3 in there. That means x is 3. So a times 2 to the third equals 24. Uh-oh. Yeah, I think I've done something to look at. So I haven't. I never have before, so I don't think I did this time. Okay. And of course you don't believe that for good reason. Okay, so if a times 2 to the third is 24, what's a? with your fingers. Get it? Okay. Well, 2 2/3 is 8. 8 times 8 is 24. What do you multiply by 8 to get 24? Now you should know the basic arithmetic facts, so that becomes obvious, but you could use a calculator. You could even write 8 times 8 equals 24, then divide both sides by 8. But you're going to get A equals 3. Okay? Make sense? Okay. Now, everybody got a calculator on their phone or whatever? You're probably going to need one. The next question. First, if you do the arithmetic in your head, of course you can, but, you're probably going to need a calculator. Of course, 18 divided by 6 is 3. Fill in the next 3 or 2 calculations you would do to test whether this is exponential. Okay, well, if you divide this, you get 54 over 18, well, that's 3. And then you get 160 over 54. And that's like 2.9, okay, let's see. It's 2 parts out of 54, 2.96 roughly, okay? So it isn't. It's not quite exponential. But 5 is 162, then the sequence is exponential. Okay. In that case, we'd have AB to the x would be equal to 3. A times 3 to the x. We'd have to figure out A, just like we did there. So characteristic of exponential function is that it has a constant growth rate. Okay. Here are the growth factors too. Here are the growth factor. Quite constant, which means you don't even have a growth factor because the growth factor is constant. Okay. So actually there's no growth factor. If you have this, your growth factor is 3. Okay, if your growth rate is 2, I'm sorry, if your growth factor is 2, what's your growth rate? Show me with your fingers. 1. Growth rate plus 1 is a growth factor. Growth factor is 1 plus the growth rate. If you have 5% interest, your growth rate is 0.05. Your growth factor is 1.05. We've been over that. It's what you would multiply to add 5%. Okay? The factor by which you would multiply a number to increase it by 5%. So you might want to review that idea. Okay. Some of the problems are about compound interest. And I'm going to wait till you've done those problems to show you the whole ball of wax on compound interest, because it's an example that goes right to the heart of what an exponential function is. Okay? Not too difficult to do the problems here. So a typical problem is RT is 4,800 times 0.8 to the t. You're given the function. Just a test here. What's the growth factor? Now, both the growth rate and the growth factor have a decimal. So if you wanted to express a decimal 3.7, you do 3.7 with all your fingers. I don't want to drop my chalk, okay? Make sense? Make sense? The growth rate is 20%. And what would you say for the growth rate? You wouldn't say 20, you'd say 0.2, right? Because 20% is 0.2. 2 out of 100 is 0.2. Okay? Yeah, 20 out of 100 is 0.2. Okay, so tell me, what's the growth factor here? Okay. Second part of what you said was right. Okay. So you just about got it. Not, but close. Okay, getting the right number. Growth factor is the base of your exponential function. Okay, growth factor is what you multiply by the number every time t changes by 1. Okay, this is your multiplier. Okay, so let's just make sure we understand this. I'm recording it. Zero is kind of traditional to write the zero there. It's just 0.8 means the same thing. So just say it's 0.8, okay? You don't have to say 0. Okay, so it's 0.8. And everybody's seeing something about a 0.8. Might have been 0.08 one time, but you have the zero in the wrong place, the decimal in the wrong place, okay? So, or maybe I saw it wrong, okay? But everybody kind of saw, at least most people kind of saw that 0.8, okay? And at least saw something like a 0.8 in almost everybody's gesture. Okay, that's your growth factor. What's the growth rate? Anybody want to give me a gesture on the growth rate? Well, I'll give you a hint. You add one to the growth rate to get the growth factor. So what would you add to one in order to get 0.8? Well, in this case, would you add the one in order to get 0.8? Point eight is one plus negative 0.2. There's your growth rate. Okay. This tells you that every time t changes by one, you lose 20%. So let's put it. Interpretation on this. If t is in years, forty-eight hundred is in clicks, maybe clicks per minute. Okay. So let's go ahead. How do you measure radioactivity? Well, traditionally measure with a Geiger counter. It has a little vacuum tube, and every time a particle passes through, a little tube with a gas in it. Every time a particle passes through, it ionizes the gas, and that creates an electrical discharge that the thing measures as a click. Okay, or the thing responds to with a click. You don't need the engineering details of that because I'm not even sure of all of them. I don't know what kind of verified gas to put in it or whatever. Okay. Maybe it's just there. That could be done, but I think it's something that optimizes it. Anyhow, that's, so think this clicks. Clicks per minute. Okay. So growth rate of negative 0.2, which is negative 20%. And if you don't know how decimals relate to percents, look it up on the internet. Make sure you're good at it, practice it a little. But fifth graders learn it real easily. Okay. And you would too. Okay. Y'all are much better than an average fifth grader. Okay. Might be a little out of practice, but your brain is much more developed and stuff, so you might make trouble with that. But make sure you do it. Okay, so the rate is decreasing by 20% every year. Now, if you decrease 4,800 by 28%, what do you get? Well, 20% of 4,800 is 960, and you could subtract 960 from 4,800. Or you could just take 0.8 times 4,800 and get the same thing. It's worth thinking about and digesting. If we have more time, we will be learning a little bit more. Okay, so this is what it means. Now, the question is, How long does it take to decrease 2,000 clicks per minute? Very simple equation you can write, and it's a very easy equation to solve from what you now know. So see if you can write out an equation that would answer this question. Once you solve it. Because again, it's real easy to solve. We'll see how it's solved, just to refresh that. But if you can write the equation, that's the hard part. And it's not all that hard once you see it. Some of you appear to be on the right track. Some of you are a little off track here. Let's simplify it. How long to decrease to this? What is it that decreases 2,000 clicks per minute? It's the rate, right? So it should be clear that 1,000 clicks per minute is the rate. Okay, now that's a connection you might or might not have made. Okay, but that's what you look for. Okay, this says that the rate is 1,000. Okay, I'm sorry, the radioactivity is 1,000. Radioactivity itself is a rate. Clicks per minute is a rate. So let me confuse my thing. Radio activity. That's what that says. You read radio, the rest of it's activity. Radioactivity equals 1,000. Now, if the radioactivity equals 1,000, then what's your equation going to be? Okay, everybody got a little closer or got the right equation. Okay, what's the radioactivity? It's R of T. Right? Now, how are you going to solve this equation? Well, it's an exponential equation. You solve a number of equations like this in the previous assignment. So what's the first thing you're going to do? Okay, well, here's your equation. We need to solve this equation. Okay, what are we going to use to solve this equation? Well, we notice that the t is an exponent in our equation. It's copied from there. You can't see it right now. That means you're going to have to change this to logarithmic form, because the only way you get to the exponent here is to get it out of the exponent by changing it to logarithmic form. Just a little difficulty, but you've done these problems, so you should be familiar with what you have to do at this point. You're going to divide both sides by that 4,800 so that you just get a plain old 0.8 to the t, and you can apply the rule. Okay. Now, if you haven't been writing out all these steps, I said it already, but I have to say it again. You need to write out all the steps. Okay. On a 10 or 20 problem homework assignment, it'd be at most 5 minutes of extra writing. And that 5 extra minutes is where you reinforce everything and make sure you understand the rules and how they go together. You have to get used to that process. Okay. So we divide both sides by 4,800. Well, that's pretty obvious, but you want to write that out. Okay. And you want to think, okay, I divide by 4,800. That's going to isolate the 0.8 to the t. Make sure you understand that. And there it is. 0.8 to the t equals 0.208. So log to the base 0.8 of 0.208 equals, equals t. Okay. Let's see, first, second, third power, fourth, fifth, sixth power, seventh power. Now, if you've been using the log-based B thing on your calculator, I don't want to see that in a solution on a test. I want you to know this rule of logarithms says this is log of 0.208 divided by log of 0.8. And I think that's approximately equal to 6 point, maybe about 6.5. Big question mark on that. Okay. One, two, three, get you down. Three more get you here. Now I'm gonna up that just a little bit. I think about the numbers. I'm gonna say it's maybe closer to 6.8. It's gonna be about 6.8 years till your radiation, till your radioactivity is down to 1,000 clicks per minute, as we measure with a Geiger counter. Okay. And if that's the safe level, that's how long you're going to have to stay away from whatever has been contaminated. Okay. And of course, many forms of radioactivity last tens of thousands, even hundreds of thousands, even billions of years. Big jump from 100,000s to billions. Okay. In other words, you're never going to be able to go back there. Okay. You're never going to be able to get close to that thing. This is a relatively short half-life, relatively quick decay. Okay, well, that's the kind of problem you have. Now, what's the process? The process is, here's your function. I recommend you identify the growth factor and the growth rate to reinforce it. It only takes, after you get used to doing it, 30 seconds. Okay? You can even abbreviate it for yourself. GR is 0.8. Yeah, I'm sorry, GF is 0.8 growth factor. GR is negative 0.2 in this case. And think about what that means. Think about what that means. Every time T changes by 1, well, in this case, T is your number of years. So every time you have another year, you lose 0.2 or 20% of what you have. Now, if the growth factor is greater than 1, then you're increasing. And hopefully that's what happens with your investments. Okay? Because there are several problems in here that involve growth rate of money. But the process is always the same. You're trying to figure out when this rate reaches a certain point. So you set the rate when this function equals a certain level. I keep saying rate because I think of radioactivity as a rate, but we've already got a rate, so I shouldn't be doing that. So here we said, okay, that means we want to find when the radioactivity is this, or when the amount of money equals this, or when the bacteria population equals this. Okay? Whatever it is, it leads directly to an equation which we can solve usually this simply. Okay? You have to know steps solving that equation. Break it down. Follow the procedure.